Now we are here to solve the question. The first question is the reluctance. Reluctance, due to the data here, we can have the formula to be length all over relative permeability times permeability of free space times what? The area of the circuit. So this is the formula that we'll be using for the reluctance now. We also know reluctance to be what? Reluctance equals to flux all over the magnetic field strength. But that one is another formula. So we are going to have this one. Reluctance equals to length all over relative permeability times permeability of free space times the area. So let's input our values through the data there. So reluctance equals to the length of the circuit is 400 millimeters, which has been converted to 400 times 10 to the power meters. So 400 times 10 to the power negative 3 all over relative permeability is 350 times permeability of free space, which is a constant, 4 pi times 10 to the power negative 7 times the area, which is 500 millimeters square, and have been converted into meters. That's 500 times 10 to the power negative 6. 500 times 10 to the power negative 6. So now let's punch it on the calculator. All over 350 times 4 times 3.142 times 10 to the power negative 7 times 500 times 10 to the power negative 6. Four times 3.14 to be giving us 18.6. This will be the value for the reluctance, and we know reluctance is going by the formula ounce per 10 per meters. Since the length is also in the question, it will be per meters. So now let's move on to find the other question, which is the current produced a flux of 800 microweber in the ring. Take relative permeability to be 350. So the second question. Current. We have a formula that magnetomotive force equals to current times number of turns. And we have a formula which that's flux equals to magnetomotive force all over the reluctance. So now let's use this formula to get our magnetomotive force by cross multiplying, making magnetomotive force the subject of the equation. So now the reluctance is 18.6 times the flux given, which is 800 microweber. The micro is 10 to the power negative 6. Now our magnetomotive force. Our magnetomotive force is 14 0.55 amps per turns. We are only having current and number of turns, so we will not include the meters as we did in the previous one. So now let's find our current now. We already know that magnetomotive force, mmf, equals to current times number of turns. Let's make current the subject of the equation by dividing 2 by the coefficient of current, which is the number of turns. So this is it. Current will now be equals to magnetomotive force all over the number of turns. Current is equals to, the magnetomotive force found here is 14.55, all divided by the number of turns. The number of turns, which is 200 turns. So divided by 200. Current will be equals to current is now 0.073 amps. So this is our calculation. The final answer for the current is 0.073 amps. Thank you.